Right. So then, good evening. So then, today is another day where we can conclude one of our chapters. That's the operating system. So then, here we have to cover the past papers of operating systems, and some of the past papers had been done already regarding the memory management, memory calculation. That part had been done. So here onwards, we are going to do the other questions extracted from past papers. And I warned you, I told you to do them and come with the answers. I hope that you did it, right? If you didn't do it, this is completely useless. The thing is, I don't want to give you time to do the questions now itself, which will be a waste of our time, right? Right. Then I will get into the questions. Right. So then last week we completed all the things, right? The file management, storage management, memory management, even that print spooler, many more things. Okay, so we'll get into the questions. So this is another 2011 onwards. We'll cover the questions. Right. Hope that you are ready. Okay, 2011, one of the MCQs. Consider the following statements about the operating systems. Then which of the above statements are correct? They want the correct statement. Ubuntu is an open source operating system. Yes, it's an operating system, open source. Not only open source, it's going to be free as well. Windows XP is a proprietary operating system. You know that proprietary means it's a licensed OS. Yes, it is. Linux is a proprietary operating system. No, Linux is similar to Ubuntu. It's free and open source. Right? So therefore that's wrong. Then the correct statements are A and B only. So for the 2011, answer is going to be the fourth. Question number 42, answer is going to be 4. Right. Then that's all for the MCQs in 2011. Then we'll move on to the writing question there. Still, this is usual. We did this in our first chapter as well, but I'll repeat that. Encircle the most suitable entry in the second and third columns. This is second column, this is third column, corresponding to the properties listed in the first column. So here we have properties. You may compare them. You have to encircle the corresponding entry. First column of the following with respect to FAT and NTFS. So we know these two. These two are file systems. So those file systems are they are file systems, and among them we know that NTFS is the latest file system, which stands for New Technology File System. FAT is the old version. It has some limited features, whereas this has more features. Right. So then when compared with the maximum file size, definitely we know that the FAT32 has limited file size, whereas NTFS has unlimited. NTFS is the latest version. It has more features. Maximum file name length, the length of the file name, I just use at candy.jpg. Likewise, how long the file name, old version has limited, modern version has unlimited. Then security, regarding FAT32 has no security at all, but in NTFS we have some level of encryption is there. Right. So then that's some level of security there, as well as some access rights. The read-write permissions are also available in NTFS, which is not there in FAT. Support of Unicode, we know that Unicode is having 16-bit representation for the characters. FAT32 does not, whereas NTFS supports it. Right. So then this is the marking. Hope that you marked like that. Okay. So it's just a question appearing in our structured paper. Then the part B that has already been done, that's a memory management question, 18-bit. We did it already, right? If I miss that, inform me. Consider the following virtual address. Yes. Then what is the page number and the displacement? We did it. And then part C, draw the operating system process transition diagram from process creation to process termination. So then this is the process state diagram. Ne? So we want the 5-state diagram. They don't need the 7-state. So you have to draw the 5-state process transition diagram. So I don't want to draw it. It's already done. It's the same thing what we had in our notebook in the theory. So then that's what the discussion behind 2011 discussions as well. Hope that you are clear. Okay. Then we'll go to the next set of questions from 2012. I think you all are okay, right? Are you? Is this okay? Fine? Fine, right? So then I'm not too fast, just revising the things how we did it, and expect that you all have done this. Therefore, no need that much of time. Right, then 2012. The type of operating system that is more suitable for an automated air traffic control system is, what is this air traffic control system? Now, air traffic control system means normally airplanes. So then whenever the aeroplanes are flying, so then especially close to the airport, so in order to land them and to take them off, they have to use the runway. You know that. The track. So the very fast aeroplane coming from the sky is landing onto the runway. And it travels a long distance to reduce the speed. Even when taking off, the same story, increase in speed on the runway. Next thing is, in an airport, normally it has limited number of runways. In Sri Lanka, I don't know, I think around 2 or 3 runways are there. Then whenever an aeroplane is to land, they should reserve the runway. Otherwise, when one aeroplane is targeting at the runway, another aeroplane is also landing from the other side, then crashing. So therefore, whenever the runway is reserved by one aeroplane, no any other aeroplane can reserve that or use it. It's dedicated to this aeroplane. Once the landing is over, another can use it. So there should be an automated system here, company-based system, that will automatically dealing with the aeroplane, and whenever this aeroplane needs the runway, they'll reserve it. So this system is the one that we are talking about, right? Automatic air traffic control system. So then by that time, whenever the aeroplane informs that I need the runway, system will check whether there are reserved aeroplanes. If not, immediately it will be reserved for this aeroplane. Then after that, if another aeroplane is asking for the runway, system says that no, it's already reserved. So this is what the air traffic control system is. Alright. Then by that time, what sort of a system is it? What sort of a operating system, what sort of a system should that air traffic control system use? That's what their question is. A type of operating system that is more suitable for an automated air traffic control system is, what is it? Multi-user multitasking. Multi-user is okay, right? The system has to be used by multiple users. Why? This aeroplane, multiple users are using it. But is that doing multiple tasks? Playing a music and doing word processing? No. One task as well as multiple users. Okay, therefore, first answer is wrong. Then second answer, single user multitasking. It can't be one user, then that's also wrong. Third one, real time. What are real time systems? We learned it. Real time operating systems. They are systems which are responding very quickly. That auto braking system. Right. Then in this case, should this system respond very quickly for the requests, or can we accept minutes, seconds delay? Should the processing and the inputs and the communication should be very quick or no need? Just think. While this aeroplane reserves it, after few milliseconds, other aeroplane is asking for the runaway. Shouldn't that be updated at the very moment where they reserve it? It seems like that, ne? So then hopefully it may be the answer. We'll see. It should be a real-time system. Very immediate action has to be taken. Then fourth one, single user, single tasking. It can't be single user forever. Then multi-threading. So then among the answers, the best should be the third one. Ne? So then 2012. Question number is 18 and the answer has to be the third. Good. So then that's the answer. That's a justification for this question. Next one, the main advantage of creating more than one partition in the hard disk. Normally in our computer, we create multiple hard drives, multiple disk partitions. In my computer, if I go to this PC, you see that I have a partition called as C here, as well as D, another partition, E, F. So they ask, rather than having one disk partition, what are the benefits of having multiple disk partitions? That means this is broken into smaller sizes. What is the benefit of having such partitions? Yes, we'll see. Separation of operating system and program files. In my computer, the operating system is Windows 11. As well as programs, there are programs like Zoom and many other programs are going on. Are they separately available in different partitions? Mostly not. So normally operating system and the program files are installed into the drive C. You see that here we have C drive. There we have the Windows folder. That has the data corresponding to the operating system. And if I go to programs files, this has the programs installed. And whatever the programs available. All are available in the same C drive. So I don't want to separate them. So then first statement is wrong. Why? Separation of operating system and program files. We don't need such. Ability to retrieve files efficiently. Whenever you have files saved in different partitions, can we get them efficiently? Now, as an example, in my computer, so I'm having multiple partitions here. One is called as C, other one is program. So then in this case, we have programs. Here we have works. So all my works are available, my class works and other works. Another partition is there, others. That means some other entertaining works are there. If so, can't I access my files efficiently? If I want to access some class work, it's definitely there in the E drive. I just go there and get it. Right? If I want to go for another one, I may go there and the other thing, just like films or songs, they are there. Then, is this providing some level of efficiency in accessing files? Hopefully, that's also correct. Easiness of making directories and subdirectories. What is this word directory? These are technical words. If you don't know these words, so they take them, right? So directory means folders. Directories, the word directory says folder. Subdirectories are subfolders. That's what the directory idea is. Right? So then in this case, how do you create folders and subfolders? Here, I just go to the partition F, then I want to create a folder. Having multiple partitions, will that support me to create folders easily? In order to create it, I just go here, new folder. I just create, give the name. That's all, right? Then if I have another partition or not, that's not a matter here. So then having multiple partitions is not supporting to maintain folders easily. Therefore, that's also not a point. Easiness of creating multiple users. Now, how do you create multiple users? That's by going to the control panel. Ne? In our computer, If I go to the control panel here, we have, where's my control panel? My search box is not working. There we have users. Where do we have it? PQRSTU. User experience improve program. Control panel doesn't have this. Here control center. To get the control panel. Right. Somehow it's there in the control panel. Here we have users, gaming, accessibility, privacy, system, personalization, apps. How can I access this? Here I went to the user accounts. Now within accounts, right? Okay. Then under the accounts, there you may create accounts, right? Here. So I have to go to the accounts. There we have the option. So then having multiple partitions is not a matter here, right? So therefore, they ask the benefits of having multiple partitions. Easiness of creating multiple users. No, that's done by going to the control panel. Easiness of taking backups. So backups are also done using the backup softwares or just copying and pasting it. Therefore, the answer for this moment has to be the second one. Files can be retrieved efficiently since they are grouped effectively. You understand how I explained that? Then for the second paper questions, this is memory management. We did it already. What is the range? Yes, we did it. Page size, still we have done this. Then 2013 MCQs. Still only one MCQ is there, right? There we have sharing a single microprocessor among number of application programs using context switching. Here, context switching is known as what? Sharing a single microprocessor. Microprocessor in the sense it's a CPU. Sharing the CPU with multiple applications using context switching. Isn't that multitasking? Very simple, right? It's a direct definition. So 2013, question number 6, the answer is going to be the second one, multitasking modes. Right. Then 2013, the writing question. This memory management done already. Then part B, that's a theory part. Right. What does it say? What is the relationship between a program and a process in operating system? So simply you need to explain the association, relationship, the connection between program and process. What is that? Direct theory. Program and process. What is it? Program is defined as simply we define this as program is defined as a set of instructions. Right, that's a program. Then what is called as a process? Process has a relation with the program. When the program is in execution, that's called as a process. Right? Then we write when a program, this association, if you write this, that's more than enough, right? When a program is in execution, it is called a process. So then this is the association between process and a program. When a program is in execution, it's going to be a process. That's more than enough. Also, you can write the earlier sentence as well. to explain what it is. Whenever the set of instructions are in execution, that event, that moment is called as a process. Good. Then part C. What is the need of having swapped out and waiting and swapped out and blocked states in the 7-state process model? Can you remember? Swapped out and waiting, swapped out and blocked in 7-state model. What is the need of having? Why we need to have this in the 7th state? Why those 2 states are there? When the process is using the virtual memory, when the processes are shifted into the virtual memory, now the states are changed into swapped out and wait, swapped out and blocked accordingly. So when the computer, when the OS is using the virtual memory, those 2 new states are required. That's all you have to write. අනේ ඇයි ඒ අලුත් ස්ටේට්ස් දෙක ඕන කියලා. ඇයි ඒ virtual memory use කරද්දි තමයි මේ ස්ටේට්ස් දෙකට අපි දාන්නේ. හරිද? When the OS uses the virtual memory, the above 2 states are created since the ordinary 5 states, what are those ordinary 5 states? New, ready, running, blocked, terminate are available. Ordinary 5 states are available within the main memory only. So this is an extra part, this since section. The earlier part is more than enough for the answer, but I just wrote this for your reminding. So why the 2 states are required in 7th state? When the OS uses the virtual memory, the above 2 states are created. That's all. Right? But this is just an extra addition. Right. Then there's a part C under the 2013 question. Hope that you will allow. Okay. Then 2014 MCQs. Right. You feel that there are only few questions from operating systems, right? Know that much. Though you learned a lot, but don't know. Now we'll see the recent papers. These are quite old papers. When it comes to the recent, there will be more questions. Right. Now 2014, which of the following is not a main function of the OS? Normally we say that OS is responsible for controlling everything in the computer. So OS does memory management, process management, file handling, file management, virus detection. Who does it? That's done by the antivirus software. Ne? So for the question number 15 is going to be the 4th. Very simple, very direct question. Right, next the 16th. In an OS, in an operating system, moving a process from the main memory to the secondary storage. What is this? Moving a process from the main memory, from the RAM. Here we have the RAM. From the RAM, we send a process to the virtual memory. Hurry. In an OS, moving a process from main memory to the virtual memory or the secondary storage in order to bring another process to the main memory is called, what is it? So we have 2 nice words. So here we have the RAM, the main memory. So then whenever the RAM is fully loaded, some of the processes here, which are called as the idle processes, are moving into the virtual memory to make more space. What is that movement called from RAM to the virtual memory? I told that clearly. What is that called? That's called as swapping. On the other way around, in the virtual memory, there are pages. Those pages are brought back to the RAM as frames. What is that process called? That is called as paging. Paging means bringing pages from VM into the RAM. From the RAM, the idle processes are sent to the virtual memory. That's called as swapping. Swapping can sending from here to RAM to the VM. Bringing from VM to the RAM is called as paging. Very important difference. Then this is asking moving from the main memory to the secondary. Main memory to secondary, that's called as swapping. It should be the third one. Right, then 16 is going to be the third. Right. Then other words, should I explain them? What is demand paging? You know what paging is? What is paging? Bringing pages from VM to the RAM. What is demand paging? Demand, on demand. When there's a demand, the specific pages are brought from here to there. That means sometimes here we have the CPU. Okay. The CPU continues a certain execution. A certain process is continuing execution. By that time, it expects a certain process that is not there in the RAM. Now RAM is searching that from the virtual memory. So now it's demanding, say, VM, the page, bring it quickly. That's what demand paging is. That means bringing the pages to the main memory whenever it is requested by the CPU. That's demand paging. Right? So shall we write that definition with a star will write demand paging. Take them into the note, right? Notebook. Demand paging as a separate keyword. We'll just take it. Demand paging. We'll write is a process of bringing the pages from the VM virtual memory into the RAM only when the specific pages are requested. Only when the specific pages are requested. That's demand paging. Anitha paging කියන්නේ bringing pages to the RAM. Swapping means sending frames to the virtual memory. ඔය දෙක හොඳට දාගන්න. Then the other word is context switching. You know what it is, ne? That's going under the process management. Swapping, fine. Interrupting. What is interrupt? Interrupt කියන වචනයත් මම කියලා සමහරවල්. That's another word found in our OS. What is interrupt? Normally in our normal usual word, what are interrupts? Interrupts are interrupting when you are and at the class now you are in the class, right? So I know that you will are fully concentrated on the class, my obedient children. By this time if your mother comes with the tea, so isn't that an interrupt for you? मैं पिस्सू के लिए मैं क्लास से फुल अटेंशन ही होया मैं මොනවද මේ කරන්නේ තේ ගෙනෙත් දීලා යන්න එහෙම නේද අපේ ළමයි අනේ අප්පා මගේ චූටි ළමයි ටික මන් දන්නවනේ Hari. Right. So isn't that an interrupt really? If you are in the real session, that's what interrupt. Interrupt means a certain event, right? Maybe positive or negative, like the tea event, right? So then you are happy whenever the tea comes, right? Okay, that's a positive thing for you, but it's an interrupt. So even in the OS the same. If there's an ongoing process, there's a process ongoing. If there's an event to break the ongoing activities, to change the ongoing activities, that's called as an interrupt. Right? Sometimes that interrupt may be to pause the execution. Sometimes that interrupt may be to improve the execution. Don't know positive or negative. Interrupt is breaking or changing the ongoing process speed, ongoing process activities. Process interrupt. Right? So then there are many different reasons the interrupts will occur. One reason is when there's a process in execution, now it's in the running state. The process state diagram. Then due to an interrupt, it may go to the block state. Does that interrupt me? Why? Waiting for an input output. Right? Sometimes the OS here, it goes back to the ready state. There's an interrupt. Scheduler will interrupt the process. So it goes to the ready state. Likewise. So then interrupts are there for a process. Since it won't let, the process will not be continuing the execution until it is being terminated. Due to many different reasons, it is being interrupted. Right? So like that word interrupt as another keyword with hyphen, right? Interrupt. It's an event, right? Certain movement. We like interrupt is an event. Interrupt is an event. Is an event. To is an event to change is an event to change. The ongoing is an event to change the ongoing process activities. Event to change the ongoing process activities. Example. Whenever a process is interrupted by the scheduler, whenever process is interrupted by the scheduler, the state changes into what? Changes into the ready state. The state changes into the ready state. State changes into the ready state. So then there are some other keywords quite not familiar to us. Okay. Then that's 2014 MCQs. Then 2014 writing questions. I think we did this part, right? This is the memory calculation part done already. Then part B onwards. What does it say? Consider the following statement regarding the OS. Process is another name for a program. Do you agree with this statement? Yes or no? Give a reason. What they say is process is another name. Process is another name for a program. Right. Will you agree with this statement? Yes or no? Process is another name for a program. Simply, technically it says that process equals program. Isn't that what they say? Process is another name for a program. Process කියන්නේ program එකකින් තව නමක්ලු. එහෙමද? No, 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 no. Previous years we said that, right? The difference. So process means whenever a program is in execution. So they are not equal. So then that has to be explained. We don't agree with that. Then we say no. You have to explain why a process is the situation when a program is in execution. Therefore, therefore the above statement, we'll say in that manner. Therefore, the above statement is false. Right? So, process is a situation when a program is in execution. So, therefore, this is false. Just write in that manner. Short answers are more than enough. Right. Then, what is the next part? Do you agree with this statement? Yes. Part C, consider the following process state transition diagram in an OS. Now, process transition diagram, we know that. What do we need to do with that? Fill in the blanks in the table given below by providing the most suitable terms for A, B, C, D, E. In the diagram, they need to identify what they are. Very simple. Process transition diagram. Here, we have new after the admission. What is this state? A will be ready. Very simple. New to ready. I said you that memorize this state diagram. Then scheduler dispatch, it goes to the running state, isn't that? Right. My spelling are wrong, doesn't matter. Then after running, release it, it goes to the terminate. Okay. Then it goes to the IO wait. So this is going to be the block state. Even very simple point, right? And then IO completion goes to the ready state. That's all, right? A, B, C, D. That's they are the answers we need. So very simple in order to do so. So memorize the states. And again, this is given the 7 state as well. Like that means from the block state, it goes to the swapped out and block state, swapped out and waiting. These are the reasons, right? Suspending, activate, IO completion, suspending, activate, likewise. Right. So then this is a 7 state diagram after the completion. Hope that you all are clear. Okay. I'll erase this and go to the next one. Right. Next, 2015. Still there are more MCQs now, right? Earlier we had only one, but now there are 3 MCQs. Okay, good. So there are comments coming. Thank you. Hope that you people have done this then. So that's what really I want. Rather than having large number of students in the class, if there are few students who are doing the things well, that's more than enough for me. Right. Question number 6. An application which requires more memory space than the maximum memory space available in the primary memory of a computer is ready for execution. Quite long sentence. An application which requires more memory space than the maximum memory space available in the primary memory. That means they are going to run an application. Say here we have application, simply it may be a program. This program needs more memory than the primary memory. Say that primary memory is of 3 gigabytes. So this needs more than that. More than 3 GB. That's what they say there. An application which requires more memory space. Application needs more memory space than the maximum memory space available in the primary of a computer. Is ready for execution. Okay, he is ready to execute. Which of the following is used by the operating system of that computer to satisfy this need? What is it? So this needs more memory than this. Then shouldn't it rely on the virtual memory? Definitely the answer is the 4th. Uh, 6, 8, 9. Then the next question. Then other answers are okay, right? RAM, extended memory, ROM, cache memory, they are known to you. Eighth one, the feature of the modern operating system which allows the automatic installation of new hardware devices connected to the computer is commonly known as, what is that? A feature of modern OSs. Okay, it's a feature in the OS, modern OSs, which allows the automatic installation of new hardware devices connected to the computer. You know this. I think I explained this, right? Didn't I? Whenever hardware is connected to your computer, external peripheral is connected, that has to be introduced into the OS. Here we have the computer running with an OS. Okay. Then whenever I connect a new webcam, right, then this works with ones and zeros to produce the images as well as sounds. Then those should be introduced into the computer. Therefore, we need to have device drivers. I said you about these device drivers, didn't I? Device drivers in my lessons? Yes, I said you, right? And even whenever a printer is connected, the printer works according to its own pattern. So therefore, whenever you connect that, still it needs to have its own device driver. So installing this driver is up to the user. We have to install that. Right? Then, whenever we do the installation, what will happen? We install that. Then, now the OS can deal with these devices since the way they are handling the bits is known to the computer. Right. But installing the device driver is quite technical work, not easy for people. Then the modern OSs are avoiding that trouble from the users. So whenever you connect a new device, automatically that will be detected. So what is that feature called as? That's called as plug and play device. So then those devices, modern devices, even the webcams we use nowadays are with plug and play feature. Even the modern printers we use still with plug and play. So whenever you plug it, they'll be detected by the OS. No need to install a particular software. So this is what the next idea, the answer, plug and play. Hope that you are clear. Then add remove hardware. So this is used to install a driver. Plug and play is the answer to the question number 8. It's the third one. Then fetch store, easy installer, no. Ninth one, which of the following is not a typical use of the RAM of the personal computer? Which is not the use of the RAM. Keeping data for processing. What is the job of the RAM? So RAM is the main memory. So main job of the RAM is to send data to the CPU, even to get them from there to here at a faster speed. So whatever available in the running state is available in the RAM now. If something is running, that's in the RAM. Why? It should be, before putting into the CPU, it should be there in the RAM. Even the results prepared by the CPU are still brought back to the RAM. Instructions to be executed still sent to the RAM and sending them to the CPU. Right. Keeping data for processing. Yes, the data that are processing are still in the RAM. Retaining information for output. Yes. Holding instructions for operations. Yes. Keeping the BIOS program for boot up. Where will the BIOS data there? Boot up process is available in the ROM. So therefore, that should be the answer for the 9th one, 5th. Then third one, providing storage for operating system. Yes, even when the OS is running, that's still there in the RAM. and all the input devices here are sending data to the RAM. All the output devices are still having things from there to here. Right. That's the 2014. Right. Then we'll go to the 2015 questions. It says that what is extended memory? For the extended memory means a certain extra memory, right? Now into the computer, I can have some extended memory. By default, it has extended storage, really, right? Normally here the internal hard drive has 500 GB. That's the internal. Then extended means we may plug another pen drive which is of 16 GB. That's an extended memory to the computer. But really it's not a memory, it's going to be a storage. These are the extended. The available amount is extended. Very simple. Not a small, not a different point. Right. 2015, this part had been done, right? Memory management part. Part A is done. Then part B. That's a nice question. An operating system uses 7-state process transition model. Okay. 7-state, what we filled earlier. For the process scheduling, a given process is currently in the running state. A process is at the running state. Fill the following table with the correct next possible state and condition for the transition. Now this is that with respect to the 7-state process transition diagram, now the process is in the running state. I'll just draw that quickly. Here we have new, then here we have ready, running, and then terminate, as well as blocked. Okay, then these are going like this, and this is going to the exit. This is going to be IO wait. This is going to be IO completion. This is going to be admit. This is scheduler dispatch. This is interrupt. Right. You can remember this 5-state diagram. Oh, 7-state. 7 now there are 2 more states to receive. What it says is an operating system uses 7-state transition diagram. Okay. The given process currently in the running state. Okay. Now it's in the running state. Fill the following table with the correct next possible state. What is the next possible state and the condition? Now you are in the running state. What is the next possible state to come? From running, another possible state is terminate. What is the condition? Exit. From running, it may go to blocked. Next possible state is blocked. Reason is IO wait. Are you clear now? So currently we are in the running state. What are the next possible state? From running we can go to ready, condition is exit. Also from running we can go to blocked, condition is IO wait. From running we can go to ready, interrupt. That's the way you have to fill the table. So just understand the point there. Harini? If it is the case, then so running, the next possible state is blocked. The reason is IO wait. That's the way you have to fill this, right? These are still available in structured paper. Right. Then next possible state is terminate. The reason is exit. Then the other state is ready. We have the ready state as well. Reason is scheduler interrupt. Right. So then this is all we need for this question. Just to fill these 6 spaces from running the next possible states. So you understand that they will maintain the question in different orders. But the concept is just the 7-state diagram, right? Nothing else. It's just talking about this 7-state diagram. You must remember that. Even in 2014, 15, we had questions. Right. Now we'll go to the next question, next set of questions, 2016 MCQs. So still in a year, we have little amount of questions, just like 3 MCQs, 2 MCQs like us. Question 16. Question number 8. In an OS, suspending the currently execution process and then resuming the or starting the another process. Suspending, another usual definition, right? Currently executing the process, suspending, temporarily stopping them, giving the chance for another process. What is that called? Context switching, ne? Direct definition. So that's called as context switching, not paging. So in 8, it's going to be the second one. Then next question is question number 9. We have only 2 MCQs still. In modern OSs, the scheduler determines the transition process from new state to the ready state. From new to ready, they focus new to ready, this transition. What is a scheduler? New to ready, what is the scheduler we use? Short-term scheduler, mid-term scheduler, or long-term scheduler. Mid-term now transition in between virtual memory to the main memory. Then short-term now very little time ready to running. Long-term means unpredictable times or taking very long time. So then new to ready takes unpredictable time. The process is just created and it collects the remainders, it collects the necessities. Don't know how long will it take to collect the necessities, then it will be in the ready state. So it's going to be a long-term scheduler. Do we have that answer? Here we have. In the modern OSs, the scheduler, long-term scheduler, determines the transition of process from new to ready. From new to ready, which of the following is correct? That's going to be the long-term schedule. Fine, that's clear. Right. Then 2017 MCQs. In 2016, we didn't have writing questions as well. Right? They are 7, 8, 12. Which of the following is a main use of complementary metal oxide semiconductor? CMOS. When will the CMOS comes into the discussion? At the boot up, so whenever you go for the boot up process, initially it runs the BIOS program, basic input output system, and after it goes for post power on self test. So BIOS will initialize the communication, post will check whether the main components are working properly with errors, and then it goes to the CMOS that is holding the user defined settings, just like the boot up order, the system clock. So those user defined details are available in the CMOS. And I said you that CMOS memory is based on a battery power as well. It's based on a battery power too. Right? So then what is that question? It's talking about CMOS. Which of the following is the main use of CMOS? Keeping inputs for processing. So what is keeping inputs for processing? That's the RAM, right? We had the same statement. RAM is keeping the inputs for processing. Alright. Then second one, holding instructions for operations. Again, that's focusing on the RAM. To continue the operations, the instructions are there. Providing space for loading the OS. See, the OS will be loaded based on the RAM. Retaining information of output, still talking about the RAM. Keeping basic input output system settings for booting up. Here, system settings. That are the user settings. So that's the answer for this question. Correct? Seventh one answer is going to be the 5. Next 8. The execution of a series of non-interactive jobs. The execution of series of non-interactive jobs in a personal computer with related to the user is known as personal computer with relative to the user. That means for a single user, it is executing series of non-interactive jobs. Jobs are the processes, isn't that? Jobs means processes, different works. Non-interactive processes are executed with respect to a single user. In that event, it can't be multi-user. Multi-user වෙන්න බෑ. Single user නේ. එහෙනම් what is that? Multi-processing වෙන්නත් බෑ. For a single user running multiple processes. Isn't that multitasking? And multi-user processing නෙවෙයි. It's a multitasking. Why? One user will do this multiple process activation. Right. Then the 12th one. On motherboard is used to expand the functionality of the computer. Used to expand the function of the computer. Which of the following is the most appropriate? Bus. In the motherboard, what is called as bus? So simply we say that bus is just like a internal cable to carry data. Now take these terms if you want, right? මේවා සමහරට මතක නැතුව ඇති ඕනෙව දාගන්න පුතේ මම හැම වෙලාවෙම notes දෙන්නේ නැහැ paper discussion එකේදී notes දෙන්නේ හිතුනොත් මේක කලින් කිරිලා නැහැ කියලා මම notes දෙනවා ඔක්කොටම ඕන නම් නැත්නම් ඔයගොල්ලෝ ලියගන්න. If you feel that this you need this, you may take it. Bus කියන්නේ cable එකක්, wire එකක් which can carry data. The clock means the system clock. How the pulses are there. Now normally in the CPU we have clock rate. So that says that per second how many instructions are executed. That's called as a clock rate. It's clock pulse. Then a RAM, we know what it is. Slot, ROM. So they are not supporting the expansion, right? Even clock is also not. Then the expansion is supported by the slot. So answer should be the slot. What is this slot word? Now they say that this is something available in the motherboard that is supporting to expand the function. What is that? In the motherboard, I just show you that some of the pictures here. Slots. When you take the motherboard, you see this is the motherboard, right? So in this motherboard, I have shown this earlier even. Now you have the places, right? Normally use red color. So this place is the one to fix the CPU, okay? And these are the places called as slots. So slots means it's just like a hole to connect different extra things. Now these slots, the one I have selected are to plug the RAMs. And here we have PCI slots to connect many other cards. Even these are used to connect the network cards. and graphic cards. So they are called as slots. Normally you see that there are 4 RAM slots are there. So you may plug one RAM card, another RAM card. Likewise, you can expand the functions by using the slots available. Here, these are the slots. Into these slots, we can plug cards. Here we have another 2 slots, RAM slots, and many other slots. So that's the idea. Simply slots means they are the ports, they are the holes available in the motherboard to plug to connect many other extra devices. Right? So then, shall we write that word? I didn't give this word in my theories. We'll say slots as another keyword. And with the hyphen, right? Slots. Right. They will like slots. Other places available in the motherboard are the places available in the motherboard to connect extra equipments such as RAM cards, CRDS, RAM cards, graphic cards, NIC, network interface cards, network interface cards, to improve the available functionality to improve the available functionality. Right. Then that's it. Then for the question number 8, yes. Now there's a question from one of you asking, sir, aren't all answers are correct in 2017 8th MCQ? Yes, when I check the marking scheme, this question, the marking scheme answer is all. That's true. Fine. There's a marking scheme answer. Why is it? There may be confusions. The execution of series of non-interactive jobs on a personal computer with related to the user is known as multitasking, multi-user processing, multi-processing, batch processing, online processing. Non-interactive jobs on a personal computer with relative to a user, for one user. It can be multi-processing as well, then. It may be a certain doubt, but in this case, I feel that this is okay. But the marking scheme answer is all, right? Due to a certain error, they have given this as all. Yes. So somehow, thank you for prompting that situation. So marking scheme answer is all. We'll just continue, right? Okay. Now for the 12th one, answer is going to be the 4th. That's true, right? Then 2017, the writing questions. In an operating system, what are the events that change the state of a process in the running state? ඔය කියන්නේ ආයතර වගේමයි. What are the, in an OS, what are the events that change the state of a process in running state? What are the events? They ask what are the events, right? What are the events in order to change the process state running? Right. So what are the events to change the state running? One event is completing the execution. Then state will be changing. Events, waiting for input or output. Then this is changing into blocked. Further, interrupt. Due to an interrupt, it will changing into the ready state. So that's all. What are the events? They want the events only. If so, one event is completing the execution. Further, I can mention like completing the execution will change. I'll just write properly. Will change the state into terminate. Next one, that will be going to terminate state. Then other one, due to IO wait, input output wait, change the state into blocked. Alright. Next one, due to an interrupt, due to the schedule interrupt. Due to the scheduler interrupt, change the state into ready. So still based on the 5 state or 7 state diagram. What are the events to change the state running of a state diagram? Right. Then okay. Then part B, explain the main actions performed by an OS during context switching. Explain the main actions performed by the operating system during context switching. While the context switching takes place, what are the actions taken place by the OS? I'll just focus on the marking scheme quickly. The thing is, this is a second question, right? So they'll expect, you can write that in any way. Just, it gives you 4 marks altogether. Right. Now this is a real order, right? Where the marking scheme expect. Whenever the context switching is taken place, we know that. So whenever P1 is in execution, that's in the running state, then it is being context switching now. This is using CPU. Alright. Then what happens? The execution of this one is suspended and assigning P2 into the CPU for the execution. That's a summary. But we need to mention that in detail. I told that in my notes. Why they ask explain the main actions. Now this is going to be quite heavy question. Main actions performed by the OS during context switching. Regarding context switching, what are the main actions expected by the OS? So one thing is the current process will be suspended. Whenever this is suspended, is that completely termination or with the intention of resuming the execution? Why do we suspend P1? With the intention of resuming it. If so, the current details of this process or simply the context of this process, shouldn't they be updated into somewhere? Where should they be updated? Into the PCB. Shouldn't that be an important information to be mentioned here? Right? So then first instruction is the currently executing process is suspended by updating its PCB with the data related to the process execution at the moment. After that, what happens? Assigning the next process to the CPU. When that is assigning, what happens? The details of that PCB, shouldn't they be loaded to the CPU? That PC was also suspended, then we have to mention that. Assigning the next process into the CPU while loading the context of the PCB into the CPU and resume the execution. This is what happens. You must mention in that manner. So then that's the work done by the OS to facilitate this. Right. So then if you are write it, I'll just use this side. Part B. The current process is suspended. The current process is suspended by updating its PCB with the CPU values. And current process is suspended. If you want, you can say P1 here, right? Okay. Then we can say that then assign the next process, maybe P2, into the CPU, then assign the next process into the CPU by loading the stored context of the PCB into the CPU, context of the PCB into the CPU, to resume the execution of that process. And this is what the next work to be done. You are clear? So then here the PCB is very important to be written here. The role of the PCB, how did I say that? P2 of the PCB. And here we have to say that these details are written into the PCB again. Clear? So you may write the answer in that manner. Then explain what will happen during the booting process of the computer. Other one. Whenever the computer is booted or started, what will happen? What's happening then? So that same order has to be told in a explained manner. So that initially it runs the BIOS. Then you have to say what this BIOS do. So BIOS is initializing the communication between the components of the computer. And after that, POST is executed, checking whether all the main hardware equipments are working properly. After that, CMOS is executed, loading the user-defined settings into the computer, just like the boot up process, system clock. And then according to the boot up device, the OS will be loaded. And one more extra statement is required. After loading the OS, the entire control of the computer is taken by the OS. OS is controlling the computer. Then after CMOS is loading the user-defined settings such as the system clock, system time, boot up device, boot up order, while loading the OS from the selected boot up device, and then take the control of the computer by the OS. So then these are explained in that manner. If I'm right, then yes, I'll write somewhere here. At first, the BIOS program is executed to load, to establish the communication, between the main devices of the computer. Then after that, pause is executed. Then pause, you have write what they are, what they stands for, right? Power on self test. I hope that you know that, right? Post is executed in order to check the errors of the main hardware such as CPU, RAM, hard disk, and data buses. Likewise, check the errors of the main hardware. If all of them are error free, then the CMOS, you write what it stands for, complete metal oxide semiconductor, is executed. Alright. They don't say what it does. What is it doing? It loads the user defined settings such as the boot up device order, system clock, etc. Then the OS is loaded according to the boot up device and takes the control of the entire computer. So that's very important. For this one, they have allocated 1 mark in the marking scheme. Takes the control, right? So in this a certain extended explanation, you write like that. At first, what's going on there, one after the other. Right? So that you can read this part. So for that explanation, 3 marks will be given in the marking scheme. Let's transfer the control to the OS. Yes, that's very important. For that one mark will be given. Right. Right. Hope that you all got the points. Right. Then you are going to the next question, 2018 MCQs. Again, there are 2 MCQs, right? Okay. Consider the following statements. Which of the above are correct? They want the correct statements. So the OS is located in the hard disk. While the boot up is going on. Yes, normally OS is installed into the hard disk. It's in the hard disk. Then when the boot up is there, still it's in the hard disk. It should be loaded from the hard drive to the RAM after running the CMOS. CMOS says that my OS is in the hard disk. Then now the boot up process will be focused onto the hard disk. Booting up event. Goes to the hard disk and pick up the OS data. Then the OS will get loaded. And initially hard disk will not be started. Initially BIOS. Another post. Then the CMOS, when the CMOS is there, it says that now go to the hard disk to start the OS. Just a director to load the OS. Then which of the above statements are correct? Disk defragmentation makes files that are fragmented on the disk contiguous. Is it? You know this well, right? It's a utility software. So then in the hard disk, the file fragments are randomly available. Defragmenter will arrange them in an order. You can remember that. That's a very simple thing. Yes. Swapping is the memory management technique where the main memory contents were not recently used are copied to the disk to make the memory available for the other processes. Is that swapping or paging? It says that swapping, what is swapping and paging? There's a difference. Moving from RAM to the VM is swapping. Bringing from pages to the RAM is paging. This is swapping. Swapping means RAM to the VM. Swapping is the memory management technique where the main memory contents that are not recently used are copied to the disk. That's correct, right? That's swapping. Third one, a file allocation table is a table that an OS maintains which provides a map of the clusters the files had been stored. Yes, that is. The FAT table, it has entries. Then all of them are correct. Question number 38. Next one is 37. Through which of the following will a device controller that controls device deals with the OS? Through which of the following will the device controller that controls the device? To control the device, what do we need? Device driver. So driver has to be there to control the device, obviously. So that's going to be the fourth as the answer. Input output management. Right. Then 2018, another question. Now these are recent papers. Okay. Consider the following diagram which shows how an abstract layer of computer system are related. Okay. Choose and write down the correct terms from the list given below through the labels A, B, C, D. Compiler, computer hardware, liveware, operating system, application programs. What is this then? On the top we have the user level, ne? All of them are users. Then assembler, word processor are there. This is related to something like this. Ne? When we continue with our operating systems, you can remember that I told this at the very beginning. Here we have users. Users are dealing with the application softwares. Word, Excel, PowerPoint likewise. And application softwares are dealing with the OS. OS will deal with the hardware just like CPU, RAM. And they are giving the reply back to the OS. OS will give them back to the application and they are giving back to the user. This is a flow. Right. So I think this is the one that they are highlighting here. Then here we have the hardware, operating systems. These are going to be the applications. But another problem, here we have A available, B, C, D. What is A then? Some example of this layer. Then there we have a word processor, database system. They are application softwares. Parallel to that, we have an assembler, language translator. Is this assembler application or system? Assembly is going to be a language translator system. Therefore, when I check my answers in the given set, there we have compiler, hardware, liveware, operating system, system/application programs. So both are covered. Isn't that going to be the A then? Right? And then here we have compiler as well. That means in this case, you find that here assembler, then I can say A is going to be the compiler. Why? Assembly is there, so I can have compiler as well. No problem. Then altogether this group is application plus system software. Ne? Application and system software. Right. Both are there. Then this is going to be the OS, this is going to be the hardware. And this is going to be the operating system. Right. Are they available? These words in the list. Compile is there. Computer hardware is there. Yes, that's D. Then liveware, then operating system is there. Yes. System application programs. Yes. So liveware are the people here. Do you have people? No, ne? So only A, B, C, D, E. Then they are fine. So we don't need to use liveware in it. Fine. Okay. Now we go to the part B there. Order 4 of the following statements in the correct sequence to describe the operations that takes place when the computer is switched on. When the computer is turned on, what are the steps to be continued? What are they? This is again boot up process, right? What is going to be the first thing to be done? The BIOS copies. The BIOS looks for the CMOS. Compile is started. System contents memory is swapped. OS loads the device driver. Triggered by series of clock ticks, CPU executes a startup program instructions in the BIOS that involves power on self-test. Isn't this going to be the first thing to be done? So this is just the understanding, right? Hari, can I say that like that? Triggered by series of clock ticks, the CPU executes a startup program's instructions, BIOS, and the post. That's the first thing to be done. Right. BIOS copies the operating system files into the memory. No, that's not. The BIOS looks for the CMOS chip to tell where to find the OS. That's also quite fair. We'll see the contents of the memory swap back. The compile is started. OS loads. Then isn't that B as the next answer? Am I correct? Fine. If CPU, if B, then B says that the BIOS looks for the what's that? BIOS looks for the CMOS chip to tell where to find the OS. That's okay. Now initially they came from the F part. They covered the BIOS, then post. That's done. Then part B says that CMOS. Okay. Then from CMOS the OS will be loaded. Right. Then what is next to do then? After the CMOS is tell where to find the OS. Then BIOS copies the operating system files into the memory and the OS starts execution. Isn't that? Then the OS will get started. Okay. Right. After the OS is started, what's next to do? The contents in the memory are swapped back to the hard disk. That's a later work. OS loads the device drivers need to control the device and gives the logging interface to the user. Isn't that the next thing? So logging interface has to be given to the user to log on. Then only the users can work on it. After that, okay. After that, there are two more to fill in. OS loads the drivers. And then compile is started. Why? Compiler comes to convert the instructions. Then after that, we can say that the contents in the memory are swapped to the hard disk. To overcome the limited memory. Are you clear? Then here we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is A, B, C, D, E, F. So this is the order. Are you clear? Harani? Then according to their instructions, this is how you set the steps of loading the OS and working the OS. The question says that order the first 4. Only 4 is required, but I just marked all of them. Clear? Right. Then I will go to the next part. This is again the transition diagram, right? That's what I said that in the recent papers, the process transition diagram is there in every question. State the transitions that could occur in a process running in a computer with multitasking OS. Right? Then you have to label what A, B, C, D are. Apo very simple, What do you mark it then? Here A, here ready to running. So B is the scheduler dispatch. Do we have that? Here we have scheduler dispatch. So that's going to be B. I'll just mark it somewhere here to save our time. That's scheduler dispatch. Ilangata A will be scheduler interrupt. Do we have that? Interrupt, that's A. Okay. Then after that, D is IO wait. Input, output, or event wait. That's going to be D then. Then input, output, event completion. That's going to be C then. So they are the ones you have to write it here accordingly. Very simple. For the process above, given give one possible reason for the following transition triggers. Right. Then for an interrupt, you may give. What is that interrupt? For the process above, give one possible reason for the following transition triggers. Interrupt. What is it? Interrupt is an IO wait, right? Okay. So then here just a direct IO wait is a reason for an interrupt. In a certain computer, the physical memory has total capacity. I think we did this question. 4 GB part. Then for the operating system maintains data structure named as page table. What is the purpose of it? With respect to the physical memory size, I think we covered this part. That's all. Then 2019, the questions. Right, an operating system uses PCB to maintain important information about each process. Read the following scenario and answer the questions regarding PCB. Rani starts computational program, computation application in a single processor computer while the relevant computations are in progress. Now you have to fill these blanks. Right. What is that filling? Rani starts a computational application in a single processor computer. So this is Rani in the computer, a certain application is started. We call this as computational application. He started computational application on a single processor computer. While the relevant computations are in progress, she starts web browser application as well. This is multitasking. While this is going on, this is the first one to start. Then web browser is also started. That's the second application. Okay, that's the other app. Application as well. In order to search for some information, we are doing like that. Write down the content that will be stored in the following PCB fields of the computing process. So in the computing application, we have the PCB. What are the values stored in this? In the computing PCB fields of the computing process, when the computing process turns into web browser process under the context switching mode. So we have only one CPU there. So earlier this computational application was running. Then this person starts web browser. So this content of this computational application will be updated and given the chance of the web browser to continue. Then they ask, what are the fields of the computational application of the PCB when this transition takes place? තේරුණාද? මෙයා කියන්නේ computational application එක වැඩ කරගෙන හිටියා. ඊළඟට මේ මිනිස්සයා web browser එකත් open කරනවා. මේක වැඩ කරගෙන ඉන්න web browser එක open කරනවා. Open කරපුවාම මේ computational application කියන එකේ PCB එකේ fields වල values මොනවද කියලා අහන්න. Very simple. හරි. දැන් අපිට හිතා ගන්න තියෙන්නේ. අපි දන්නවනේ context switching වෙනකොට මේකේ current details ටික ලියලා තමයි මේ suspend වෙන්නේ. එතකොට දෙවෙනි process එක load වෙනවා. So they will mark the answers as they expect. Then they said program counter. Now we have a value set given, I think. Okay, doesn't matter. No values are given, right? Doesn't matter. What is PC, Bude? Program counter. What is it holding? Program counter is holding the address of the next instruction. When this is suspended, what is the next instruction to be executed? That is the address of the web browser application, isn't that? When this is suspending, next one to come here is web browser application. So then that's the address, right? Program counter holds the address name. Then here it should be the address of the web browser application. That is the next instruction. Okay. Then process state, ready, running or blocked. Under the computation application, what is the process state now when this is given the chance? That's going to be ready, obviously, isn't that? මගේ තේරෙනවද? මෙයා suspend වෙනකොට එයා ready වෙනවා. Early it was in the running state, now it comes as ready, while making web browser goes as running. හරි. That's all we need. What is meant by contiguous file allocation? මතකද? Recently we did it. What is meant by contiguous file allocation? What is it? All the file fragments are assigned into close by contiguous close by clusters in the storage ne. That's called as contiguous file allocation. Then write down one drawback of contiguous file allocation. One drawback of contiguous. One such drawback, what is it? Contiguous now, it creates external fragmentation. On the other way around, whenever we have contiguous file allocation, can we grow the file? Not possible to grow or update the file. If it doesn't have close by free spaces, how can you update that? However, contiguous allocation is feasible to store set of files in CD-ROM. Why is it? In a CD-ROM, contiguous is good look. CD-ROM now. Here we have CD. If it is CD-ROM, what happens? It's CD read only memory. If so, are the stored data updated, modified later? Not at all. CD-ROM, no updating, no changes are done. Then whenever you save some files continuously, this is the file 1, then this is the file 2, will there be growing of the file later if it is CD-ROM? It's not. Why? It's fixed. Then whenever you pack your data, they'll be fixed, no need to update it. Then contiguous is fine. Why? Since it is contiguous, data reading is also faster. Why? Segments, fragments are available close to one another. Then for CD-ROMs, contiguous is the ideal. You understand that? Then there we can write the answer. How do we write it? We can say that CD-ROM read-only memory, CD read-only memory, is a type of read-only memory, is a type of read-only memory, so that the written files are not updated later. They are fixed. Right. They are not updated later. Therefore, the saved, or else we can say written, therefore the saved or written file fragments contiguously need not to be changed, need not to be changed, need not to be changed. Alright. The another point is also reading the fixed files will be faster in CD-ROM. Therefore, contiguous file allocation is suitable for CD-ROMs. And so then there we have to say that they are not updated. That's the main reason why this is going to be good for CD-ROMs. No growing is done. Whenever the growing is expected, the out comes. Why we don't have enough space to put the updated values next to the existing blocks. Right. Then, right. Then, however, yes, why CD-ROM? Okay. Then, in addition to the normal data items, write down one other information that will exist in file block in linked file allocation scheme. Can you remember the linked allocation? In addition to the normal data. In linked allocation, how it is going to be? I said that already. Linked allocation, now this is the file. So at first the file has to be fragmented. This may be F1, F2, F3 as well as F4. Then in addition to that, what else is required? We need the address to the next block. That's what they ask. In linked allocation, in addition to the file, what else is there? Why? Other than F1, it has to have the address to the next block that will link the next block. Even this has the address to the next block. Even this has the address to the next block. Even this has the address to the next block, but that's going to be -1. Can you remember that? Then the answer is other than the file fragment, each block has the address to the next block. Other than the file fragment, address to the next block is expected to be there. Right. Then I think we did this, right? Didn't we? Yes, right? Paging part we did, didn't we? Yes, 8200 we did that. Yes. Fine. Then write down one advantage use of the page table bring respect to the program size compared to the physical memory. Then write down one advantage that the use of page table bring with respect to the program size compared to the size of physical memory. So I think I wrote the answer as well. One advantage of using page table with respect to the program size. Yes, I wrote that. So program size is quite larger than the memory size. Then we need to have the virtual memory to be used. So that page table assisting to manage the available RAM with the existing. Now it says about with respect to the program size RAM. This is a program. What is the use of page table? So page table supports you to deal with the virtual memory. Right? The question says write down one advantage that the use of page table, bring with respect to the program size compared to the size of the physical memory. Compare the size of physical memory. What is it? Then you have to say that when the program size is larger than the RAM, the OS uses the virtual memory. The OS uses the virtual memory so that the page table helps to maintain the entry of the specific blocks of the virtual memory and the RAM to continue the execution. Right. So that supports to map the virtual memory and the physical memory. That's the idea. Right. Then give one reason as to why a particular range of processes could be absent in physical memory. We did this. Why processes can be absent in the physical memory? So that those blocks may be overwritten by some other processes. So then those blocks are not vacant. Further, that process might have been terminated due to many other factors. So that that is not a valid entry. What do they say? Give one reason as to why particular page of a process could be absent in physical memory. In this case, they said that this present absent bit, where is it? On the last part, right? Last bullet, the present absent bit indicates the validity of the entry. If the bit is 1, it's valid. 0 is invalid. 0 page is not in the physical memory. Now they ask that situation. Why the page is not in the physical memory? That means this is not valid. Physical memory is RAM. It's not there in the RAM. Why is it? The question is asking, give one reason as to why the particular process could be absent in the physical memory. Why that process may be absent? Now simply this is the RAM. This is a virtual memory. This is the RAM. Right? This is the page table. So page table has all the page numbers and the frame numbers as well as the present absent bit. Correct? I'll just mark this as 0, 1, 2, 3, 4 likewise. This is a virtual memory. 0, 1, 2, 3, 4, 5 likewise. Then these are the page numbers. These are the frame numbers. Then page numbers 0, 1, 2, 3, 4, 5 likewise. it says that page number 1 came from frame number 2 and this is valid. Then page number 3 came from frame number 1. That's valid. You are clear? So then this says මේක හොඳ මතක තියෙනවනේ දැන් ඉතින් ආයෙ මම මුලින්ම කියන්න බෑ page table එක මතකයිනේ page numbers මේ page 1 කියන එක කොයි frame එකෙන්ද ආවේ frame number 2 එකේ තිබ්බ එක තමයි frame number 1 වලට ගිහින් තියෙන්නේ page number 1 වලට page number 3 වලට ඇවිල්ලා තියෙන්නේ page number 3 වලට ඇවිල්ලා තියෙන්නේ frame 1 වල තිබ්බ එක මෙයා එතෙන්ට ගිහින් තියෙනවා හරි දැන් මේ entry is valid rule valid means we can call them back at any time. That means this page number 3 has to be called back into frame number 1. We can call this back. It's valid. It's a valid entry. They ask why this is going to be invalid. Now in the page table, they said that whenever we move it, the specific frame moved into the frame number 1 had been moved into page number 3. That's okay. We did it. But now present absent bit is 0. Why? That is that you can't call this back to the RAM. It's not available in the physical memory. Hey, me process එක ආයි physical memory ගන්න බැහැ. Since he is telling that absent. They ask why. One reason is if that process has been terminated. මොකක් හරි reason එකකට මේ process එක terminate වුණා. Due to the we said that termination reason. Due to the parent process termination, the child process are terminated. මේක child process එකක්. එයාගේ parent process එක close වුණා. එහෙනම් this already closed නේ. ආයෙ මෙයා call කරන්න ඕනේ නැහැ main memory එකට. It's invalid. That's a primitive reason. හරිද මං කියන එක? ආයෙ මේකට ගන්නෙ නැහැ. ඒකයි උතන invalid වෙන්නේ. තේරෙනවද මං කියන එක? Do you understand that? So then this entry may be invalid. Why we don't need to call that page back to the main memory? It's useless. So one reason is the process might have been terminated. The other event is at this moment this has been turned into 0. Earlier the present absent bit was 1. It was there when I'm moving it. Now it turns into 0. Why? At this moment, you can't bring this into this page. If you can't bring this page into this frame. Why? This is already in use by another process called as P5. ඒක තේරුණාද? මේ process එක ඇවිල්ලා P1 කියන එක ගන්න. හරි. ඉස්සලාව process එකක්. මේකට P1 ආවා RAM එකට. හරි. P1 එයා idle හන්දා OS has moved that into the virtual memory. So frame 1 had been moved to page 3. ඒක හරි. ඊට පස්සේ this is free නේ. Now since the main memory is free, another new process came called as P8. Since this is free, that has been assigned to this slot. Now it's free. The one it was had been moved into the virtual memory. At this moment, this slot is in use by another process. Then at the same time, whenever a new process is assigned into the same frame, this bit has been turned into 0. Why? At this moment, you can't call this page back into the frame since it is used by P8. P8 එක අල්ලගෙන ඉන්නේ. ආයේ මේ ඉස්සෙල්ලා එක්කන මෙයාට ගන්න බෑ. ගන්න ගියොත් P8 loss වෙනවා. ඒක නම් ගන්න දෙන්නේ නැහැ. After some time, this P8 has been submitted to the CPU and finished the execution. Then this P8 is no longer available in it. Now this is free. Then this present absent bit turns back into 1. Are you clear? It was make එක කරනවා. That means now it's okay to bring this back into the place where we had 1. හරිනේ. ඔන්න ඕකට තමයි present absent with තියාගෙන ඉන්නේ. So then the reasons why the specific main memory is invalid, one is the process might have been terminated, other event is the specific block, specific frame might have been used by some other process at this moment. Is it clear? Correct? Okay, so shall we write that as a proper note? Correct? So that's the use of present absent bit in this case, right? Okay, so shall we take this drawing and I'll send that as a picture, right? Okay, and yes, we have P1 now. New process P8 comes into this place. Okay, right, so leave the space. I'll give the photo here, then you can just copy that. These are page numbers. These are the frame numbers. These are RAM. These are page table, page number, frame, present absent bit. Okay, so light, leave the space. We light the present absent bit, the present slash absent, the present slash absent bit indicates, present absent bit indicates, present absent bit indicates whether, present absent bit indicates whether the specific, whether the specific entry, whether the specific entry related to the RAM, entry related to the RAM, within like say frame, entry related to the RAM, within like say frame, is vacant, is vacant, is vacant to call back, to call back the page, to call back the page into the RAM, to call back the page into the RAM, call back the page into the RAM. Full stop, and we'll go to the next point. Sometimes the specific frame, within like say frame number 1, sometimes the specific frame, within like say frame 1, sometimes the specific frame might have been occupied by, another new process, which will say P8, another new process, which will say P8, another new process, which will say P8, so that another new process P8, so that it is not possible, it is not possible, it is not possible to bring the page, to bring the page from the VM, into the main memory, into the main memory, into the main memory. Full stop and continue. At that moment, the present absent bit, at that moment the present absent bit is turned into At that moment, the present absent bit is turned into 0. Turned into 0. Informing that it is invalid. Informing that it is invalid. Right. Next point. Whenever the new process, we're going to say P8. Whenever the new process, we're going to say P8. Whenever the new process P8 is removed from the RAM, now the present absent bit is turned into 1. Since it is possible to call the page into the RAM. Call the page into the RAM. Right. Next point. Sometimes the specific process may be terminated or removed within brackets, right, due to the termination of the parent process. So that the specific process in the VM is not called back to the RAM, by making the present absent bit into 0. Right. Then give me a small second. I'll come very quickly within 2 minutes. Right? Give me 2 minutes break. Yes. Shall you all have a 5 minutes break then? The prayer break and everything. Yes. Then I'll start 2019 MCQs. Right. So then in 5 minutes I'll come back. Right. Now it's 7:20. We'll start it. Okay. Right. So shall we continue back? All are ready? So I thought that today it will be, I could stop the class earlier since thinking that I could finish this very early, but no, right? No. As I remember that I know that there are few MCQs in each year, so then I can quickly finish this. Napissuda neda? Tawa එහෙමමයි. Right, we'll continue. Right. Now, 2019 MCQs. Okay. Which of the following? Which of the following is a hardware device that maps virtual address to the physical address? What is that? Now, this is another tricky question, Puti, right? They ask which of the following is a hardware device. It's a hardware, physical device that maps virtual address to physical address. Isn't that the page table? Isn't that the page table? What is page table doing? Mapping the page number with the frame number, right? Do you understand that? So page table is mapping the page number and the frame number. What this question says, it's mapping what? Device mapping virtual address with physical address. They'll map virtual address with physical address. Are they same like this, virtual address and physical address? No. Virtual address and the physical address are found in at the very beginning. Not with this. Can you remember that? At the very beginning of our OS lesson, we said that here we have the CPU, here we have the RAM, then CPU needs data from RAM to be executed. By that time, CPU informs the RAM using the logical addresses. The RAM is maintaining the addresses on its own, which are called as physical addresses. For the same blocks, RAM are maintaining addresses, they are called as physical addresses. CPU calls for the same locations using logical addresses. It's also called as virtual addresses. Then this is what the incident for this question. Right? Then in order to map these two inside the CPU, it is using MMU, which is a special hardware unit. Memory management unit. It's a hardware part. You okay? So then that particular hardware will convert the logical addresses generated by the CPU into the physical addresses to be handled by the RAM itself. So it doesn't have any relation with the page table, pages, frames. No. You okay? So then, since it's a hardware, obviously it's going to be MMU, memory management unit. Right. So then the answer is the fourth one. Right. Then the question number 11. On his single processor computer has single processor, a user starts a spreadsheet application and creates a new spreadsheet to get some information required by the spreadsheet. Now it's a certain story. Now if you can't remember this, you better take them into your notes, right? There's a single processor computer. The computer has one CPU. Okay. In a single processor computer, user starts a spreadsheet application. Now this is running with spreadsheet. Okay. Spreadsheet application and creates a new spreadsheet. To get some information required for the spreadsheet, he opens a large database using DBMS. This is the first thing. Then a large DBMS is started as the next application. Just like in the earlier case. ඉස්සලත් මතකද අර මොකක්ද එකක් application එකක් වැඩ කරන ඉඳලා web browser එකක් open කරා කිව්වේ. Using a DBMS. After completing this spreadsheet, it saves it. Then after doing this one, this is going to be saved. So saving is done on the hard disk, right? Which of the following operating system features being used by the above user? Context switching. Is any context switching? Yes. Why? The spreadsheet is switched to the DBMS. Starts a spreadsheet and to open the large database, there's a context switching. Is any file management done? File handling? Why? They say that finally after finishing this, the spreadsheet saves it. Saving it means it's going to be a file name and everything has to be there. Then virtual memory. They say that large database, right? Large database means it can't be handled by the main memory itself. So it may use the virtual memory as well. So therefore, based on those keywords highlighted in the question, it uses all three features listed below. Then what is the answer? All A, B, C. Right? So for the question number 11, 5 is the answer. Right. Then the next question, 14. Consider the process transition diagram in the figure. Now I said to you that process transition diagram is there all the time. If the transition shown in the following, one process block for input output, then scheduler picks another process. Input output completed. 4 is IO completion. So there is going to be a IO completion. Right. IO completion goes from where to where? You can remember the diagram. So then completion means you are in the block state. Now this should be blocked. And then this should be ready. Block to ready. And also it says that third one scheduler. First one is process blocks for input output. Then this is IO wait. One is IO wait. Then IO wait comes when A is going to be in the running state. Isn't that the analysis? So they are giving the same question in different orders. Then what are the states indicated by A, B, C? So A is running, B is blocked, C is ready. So fourth one is the answer. So very simple, just to analyze that. 14, 4 is the answer. Then 49. Which of the following is not information stored? Not, right? Whenever you read the question not, underline that to emphasize it. Which of the following is not information stored in a PCB? You know what PCB is? That's assigned into each process, which is not there in the PCB. Free disk slots. Free disk slots. Disk blocks that could be utilized by process. Is this in the PCB? Normally PCB has details for the process, right? Whatever the process details are there. This is something storage. Regarding the storage, it doesn't have. So it should be 1 as the answer. We'll see other one, memory management information of the process. Yes, memory management information of the process. It's dealing with the process. Program counter. Yes, definitely there. Process identification number, PID. Yes. Process state. Yes. Then answer has to be the 1. Right. Then which is not there in the PCB. Then 2020 part A. Okay. An operating system uses PCB to maintain important information about each process. Read the following scenario and answer the questions. PL starts a spreadsheet program on a single processor computer. This is scenario. It's talking about PL. Single processor computer. So here we have one CPU. PL starts spreadsheet. So spreadsheet is the first thing. That's the first application. On a single processor computer to use the budget.xls. They have given the file name as well. Right? File and that file that he saved day before. This was already saved. He also he's also running a web browser that he uses to check his mail. Then web browser is also running. This was already saved on the previous day. At a particular time, the operating system changes the process state field of the PCB of the spreadsheet. So spreadsheet, there's a PCB. So at a certain time, the field of this process PCB changed from running to block. So then under the process state, it is changing from running to block at a certain time. Give one likely reason for this transition. You may understand that. This is a single CPU. Now spreadsheet is running. Then web browser is also running. Context switching is going on. At a certain time, the PCB of the spreadsheet changes the state from running to block. Why the state turns from running to block? What is the reason in our 5-state diagram? That is for input-output wait. Then what is a likely reason for the spreadsheet for this to happen? Then it should be definitely an input-output wait situation. Then you may convert that into the spreadsheet. What are the events of I/O wait related to a spreadsheet? You understand that? Spreadsheet එක running ඉඳන් block වුණාලු. එහෙනම් අනිවාර්යෙන් IO wait එකක් නේ. ඒගොල්ලෝ අහනවා නිකන් IO wait කියලා හරියන්නේ නැහැ. Spreadsheet එකේ මොන reason එකක් වෙන්න ඇද්ද මේ change එකට? Then in our side we have to think that definitely this IO wait. Now we may identify what are the IO wait situations in a spreadsheet. What can be? Sometimes the spreadsheet may produce an error message. Among IO waits when the program is in running state, if it produces an error message, until this is confirmed to say OK or cancel, the user has to click on OK or cancel, right? That's an input-output wait. Then can't that be associated with the spreadsheet? Whenever the user enter a wrong formula or wrong something, it may produce an error message to the user. So until that error message is completed or fulfilled, the process is in the block state. It's waiting for the user input. So you can write like that. Right? So it's waiting for your input or output, not resource unavailable. IO wait ready running to block. You can remember that. 5-state diagram running in a block 20. IO wait input output. Then mention one of the input output wait event for the spreadsheet. Correct? So the best answer is that one reason for this one is the spreadsheet may produce an error message the spreadsheet may produce an error message. May produce an error message which has to be completed by the user. Then you can say that until the user completes the message, the process is in the block state. Until the user completes the message, the process is in the block state. Right? So that's the reason why it may be put into the block state. Okay. And if you have doubts, inform me, Putty, right? Hope that you are continuing well. Right. Then the second one, when the state of the process changes from running to ready. Now running to ready, when the state of the process changes, example running to ready, the value of the machine registers are stored in the PCB of that process. Why is it important to store them? When the state of the process changes running to ready, that means the process is in the running state, it goes to ready. Values of the machine registers are stored in the PCB. So that says that the process is in the running state. Now that goes to the ready state. Then the values related to the CPU are written into the PCB. Then what is the reason? Are you clear? Then there's a process that is in the running state, it goes to the ready. Then the associated values of the CPU are written into the PCB. Why? This is due to the context switching. The process goes to the ready state in order to resume the execution later, so that the previous values of the CPU should be restored to resume the execution. That's the reason why the register values are written into the PCB. හරි මං කියන්නේ running level එකේ ඉන්න එකන ready වෙන්නේ ඇයි context switching හන්දානේ. So it has to be resumed later. To resume them later, the CPU values definitely to be restored. එහෙනම් ඒවා PCB එකට ලියනවා. ඒකයි. හරිනේ. Then we can write it like the process changes into ready state in order to resume the execution in order to resume the execution back according to the context switching. Therefore, the current CPU register values must be updated, saved into the PCB, which are used when calling them, which are used when resuming the execution at a later time. At a later time. So that's why we need to store them in the PCB. You know this. Now another question. The block size of the disk is 4 GB file allocation table starting from block 300. It gives the blocks of maximum.py, not the block of the file is indicated by -1. Write down the value of an important file number. Right. Yes. I'll keep this question to be done on the next day. This is regarding the index allocation. Right. So we'll see how these questions are done. For the moment, I'll just leave it. So we have yes, only small time to do. Then this is a fresh question again appearing in our new papers. Right. You see that 2020 such a question came. And in that year, we have that memory management question as well, right? 16-bit virtual memory address. The normal paging question is also there, while having the storage management question as well. So these are newly created questions in the new syllabus, so closer to you. Then if I go to the next year question, I think we did all up to this. Then 2020 MCQs, we have the questions. Even in same 2020, this 2021, I think, yes. 2021, still we have another question. No, 2021, we have this question, right? 2021, we have the next question, right? So 2022, still we have a question from that part. So then that's a new trend, right? That's what I wanted to highlight. So don't worry, I'll do that on the next day freshly. Until then, we'll complete the other MCQs quickly, keeping this part to be done later, right? Okay, so I'll do this B part in 2020. Then this part has been completed already. Now we'll go to 2021 MCQs. Ne? Yes. Amra logs into the single processor computer and starts the program to work his presentation. He opens up a web browser too to get some information. Consider the following process state transition diagram with respect to the process corresponding to Amra's presentation program. Consider some reasons for the above state transition. So new, ready, this is a 5-state diagram. Reason 1, Amra saving his presentation on the hard disk. Operating system scheduling presentation process to the run on the processor. Operating system suspending the presentation process to let the web browser to run. The finishing of saving the presentation on the hard disk. Can you understand the event? In single processor computer, one CPU, presentation is going on as well as web browser is there. Then context switching. Now presentation is first, then it has its own PCB, then web browser has its own PCB, then the context of the CPU are changing. Now according to the 5-state diagram, we have to illustrate that. So here under the A situation in the transition diagram, ready to running. Then this is going to be running to ready. Okay. Then 1, 2, 3, 4 are explaining what it is. And here we have D as well as C. So which of the following gives correct combination of reasons for the transition from A to D? So now you know these transitions. Ready to running will be a scheduler dispatch. This is interrupt. This is IO wait. This is IO completion. Now you have to initialize them parallel with the this side. I'll just write that dispatch. Hurry. Then this is IO wait. This is IO completion. Hurry. Whereas this is going to be interrupt. Now we will match with this given statements. Amra saving his presentation on the hard disk. Now it's running saving. Okay, we don't know what it is. Operating system scheduling presentation process to run in the processor. Operating system is scheduling the presentation process to run in the processor. Operating system suspending the presentation process to let the web browser suspending means now we are in the running state, it goes back to the ready state. Suspending, that means this is related to B. Am I correct? Suspending කියන්නේ running වල ඉඳලා ready වලට යනවා. එහෙනම් ඔන්න B කියන්නේ third එක. We'll check. So this is B2, no. B3. This may be the answer, right? Then no argument. We'll see. A is too low. බලන්න. A කියන්නේ dispatch. That's correct නේ. Operating system schedules the presentation to run. Schedule dispatch. Then the finishing and saving the presentation on the hard disk. That is C. IO completion. Then D is IO wait. D කියන්නේ third one. D කියන්නේ one, first one. Amra saving the presentation. That's okay ne? Why? When the presentation is running, it will be saved. Saving means they need to use the hard disk, not the RAM. So hard disk is an input output. At that moment, we wait for the hard disk. Once the saving is completed, now it goes to the ready state. So then the answer has to be the second one. Are you clear? Right. So the 11th one, it's the second as the answer. Are there doubts? So this is completely based on understanding. You may compare these details with the knowledge you have. Definitely 5 state diagram is there in every paper. Understand the level of questions. Right, next one, a page table is, now they are talking about page table. A computer hardware unit. Is page table hardware? That's memory management unit, right? A data structure that keeps information about pages that are in the processor cache. Processor cache? No, it has a page table, that's okay, page details, but not in the processor cache. A hardware component, not hardware. An operating system data structure that keeps virtual to physical address mapping of process pages. Isn't that the answer? It's operating system storage. Piece of process hardware, no, answer has to be the fourth one. That question is also 10. I think early one has to be 10. This is low. Right. So that's very simple. Then the question number 12. That's based on memory management, the storage management. So we'll leave that on to the next week. Then part B. Okay. Explain one way in which barcode technology can be beneficial to the library management system. That's not OS. Why barcode technology is beneficial to the library management system? Library, lending and returning books, barcode. It's not OS. Whenever you use barcode, it's from unit 1. It is making the lending and collecting book faster. Why? The book details, member details need not to be entered by the keyboard. So just expose the barcode reader to the barcode, quickly detecting the book and the member card. So its process is going to be quicker, as well as with less errors when compared to typing them. So the answer is quicker to lend and return books since no typing of data from the keyboard. That's one reason. Other one is more accurate since the barcodes are entered and detected automatically. So accurate and faster are the reasons. Since it is there in the question, I just add that into this part. Most modern computer has multiple processor in it. Explain one way in which multiple processor in such computers can be beneficial. Multiple processors. So multiple processors in a computer will be, this is a computer having one processor, that means CPU 1 and another processor CPU 2. What are the benefits of having multiple processors? Can continue parallel processing, which will be faster to complete our execution. Right? It can continue parallel processing so that more than one process can get executed at a time. More than one process can get executed at a time using the multiple CPUs available. Using multiple CPUs, it will continue the execution. So 1 mark is given. 2 marks. Explain what is meant by volatile memory and write down one example for such selecting from the list below. What is volatile memory? They are very simple. Volatile means a memory where the data are lost when it is disconnected from power. Then they want us to write some examples. What are they? Volatile memory, DRAM, that means RAM, that's fine, right? Hard disk is not volatile. L1 and register, all of them, right? That means DRAM except the hard disk, L1 cache, as well as registers. So they are going to be volatile memories. Part B, a student asks you how all applications stated by him execute simultaneously although he has a single processor computer. Write down the explanation. How all the applications started are going to be executed simultaneously using single processor. What is that? That's context switching, right? According to the context switching concept, according to the context switching concepts, each process uses the CPU only for a smaller time period within brackets, right? Milliseconds. milliseconds and suspending the execution by allowing another process to execute while the earlier process resumes the execution later. So then in that manner, then we can write some more. Therefore, each process continues the execution. Each process continues execution one after the other by switching the CPU in short time intervals. In short time intervals. This is my answer. Somehow you may narrate that. So then all the processes are switching in very short time intervals to use the CPU. So suspending is done, resume the execution, likewise. Right. Then what else is there? That's a 3-mark question. Then programs whose size is even larger than the size of the available physical memory of a computer could be executed on it. How can this be possible? Programs whose size is larger. Program size is larger than the physical size. How can this be possible? 4 marks. That is with the help of the virtual memory. Second one. Due to the use of the virtual memory, the process, the larger process use of the virtual memory, some of the data of the process are moved into the virtual memory, we might say hard disk, while the main areas are kept on the RAM to continue the execution. Kept on the RAM to continue the execution. Then what happens? The data on the virtual memory are recalled back to the RAM to continue its execution, so that large programs can get executed with the help of virtual memory. So whenever the memory size is larger, smaller than the process size, so this is the RAM. Assume that RAM is of 2 GB, we have a process P1 which is of 3 GB. That's what they ask. In order to get this, some of the idle data are moved into the virtual memory and make this space free. And from here they are being sent to the CPU, and whenever they are executed, they are being finished and bringing the things from the VM back to the RAM to continue the execution. You know this, we discussed that already. The last one of that, when linked allocation is used in disk space allocation, each file needs slightly more storage space than when contiguous allocation is used. Explain why is it. When linked allocation is used, each file needs slightly more storage space than contiguous. Why? In linked allocation, each fragment has to maintain the address of the next block. So that's also some information to be maintained. In linked space allocation, each file fragment F1, this is a data set, other than it has to have the address to the next block. Address to the next block. So likewise, if you have many other fragments other than the data item, these are also collected. So then it has more space than the contiguous. Contiguous now they are still connected close to one another. They don't have the address. Then for this one we can write it like linked allocation maintains the address to the next block other than the file information. The contiguous allocation maintains only the file information. Therefore, linked allocation needs more storage space other than the file size. Why? It has to have this address to the next block to be maintained. That's the nature of the linked allocation incident here. Alright. Then you see that this is the 2021 paper, right? Now understand, these are the recent papers we have. So one before the last paper. Then get the knowledge. How will you get these questions? So just to give some short answers, giving you 4 marks, 2 marks, 3 marks. According to that, you need to narrate your writing. And also we have 22 questions. So I hope that we'll continue that discussion on to the next week. Right? So again, I think this discussion will take some other time. I think so we have to calculate those questions with some more. I gave the other tute as well earlier. The other than this past paper tute. Other than the past, I gave you that memory management questions as well, didn't I? This one. I gave that, right? So then here we have some more questions to be done under that memory management part, right? So then, yes, where is it? The past papers. These questions, right? So out of this, there are some more questions for you to do. Therefore, so next, I think the next 3 hours, I need it completely to complete this part. especially with the storage management. They'll be there in your new syllabus, right? So be ready for that one. Uh, then finally I wrote like this, right? Okay. Then again by next week, really I'm teaching you that important part. I taught it already, but I'll do the questions for you to open your minds how to face such questions, right? And to complete the other MCQs in 2022, then again my advice is today do these questions again. You might have done this already, fine. But I'm telling you that now you got the ideas. Then take the tute again, do these questions by writing the answers on a separate sheet. So when you're doing questions in the past papers, don't mark the answers in the question paper itself. Mark them on a separate sheet. Then questions will be there as it is again. So again I'm telling you that take the printout of the question paper and write the answers on your own since you know how to write the answers now. Then write it and double check whether your answer is correct or wrong. Right? So then we learned. So in our theory discussions, we spend huge things in memory management and many more things. So we finished that part. So again, I'm telling you that do those questions and get the knowledge. So very important, right? So then hope that you all are fine here and do that homework on your own. Then that is your improvement. Okay. Right. So I'll stop here. Hope to meet you on coming week by finishing this storage management part and the past papers. Then the other week we can start the network chapter. Fine. Okay. Then good night. See you then.